The objective of the program was to use two different technologies, one of which we've developed through a partnership between astronomy and electrical engineering, and the other of which has been developed through the geology program, to look at samples of rocks in caves to see if we can identify signatures of life.
Parts of the instrument that we would bring into the cave, the first being the laptop, which is running the software to operate the instrument. The second is this electronics box, which controls all of the circuitry. One is to turn on an infrared lamp, which is illuminating some kind of sample, so like a rock like this. We would place the sample at the focus point, and we collect all that information on the laptop, and we can see a spectrum.
And so basically what happens is that we shoot this laser here. As it passes through, it analyzes the sample, and that light comes back through the lens. The screen's right here, and so it comes to the screen and we could actually see the spectrum that we got.
So we have two types of equipment. One is we're calling PASA, so that's Portable AOTF Spectrometry for Astrobiology. That's the one that was developed here at NMSU. And as far as we know, this is the first time that someone has lugged that 2 miles into a cave and made these measurements and been able to say, based on those data, that these samples were crystallized under the influence of bacteria and these samples were not. The other equipment was laser-induced breakdown spectroscopy, and that has not been deployed in a cave in a way that, in a backpack model.
The two different instruments tell us two different types of things about the rocks that we're looking at. And so the idea is by using the two technologies together, we can gain a better understanding of the nature of those rocks and whether they're inhabited by microbial colonies.
We got to a hall in the cave, or a fairly large cavern, and spread out the equipment. Then we collected 20 samples and then took them to our instruments and analyzed them there with both instruments. Then we set off with the instruments to analyze samples on the wall, so we can actually do it without having to collect the material, which would be the way you would operate in the future, right? That you don't have to collect samples. I can get all the information I need in the field, and I don't have to break a rock off the wall to do it. You could analyze thousands of samples in the field. They performed as we expected. I think that, of course, we would like them to be lighter. The smaller we can make them, the better.
Caves represent an extreme environment. They're very climate controlled, they have no access to sunlight, and so any life that exists in these caves is very unusual and rugged, and so we'd like to be able to identify those signatures, because ultimately we'd like to be able to send our instrumentation to another planet to look for signatures of either current life or past life on those planets.